Okay, in the last video, we learned about this function called the derivative that will tell us the gradient anywhere on another function that's curved, and the gradients are changing. There's this new function called the derivative that tells us the gradient for any x value. Well, it turns out there's a shortcut. There's a really easy way to find the gradient, and I'm just going to show it to you. If you've got for all of our questions, if you've got a function that's in the form of ax to the nth power, if it's in this form, then the derivative is really easy. All you do is take the exponent and multiply it by the number in front, the coefficient. Go n times a. That's half your answer. And then take away 1 from whatever the power is, the power minus 1. So this one would be 3 times 4, 4x, and then we bring this down 1, 4x. It's 4x cubed. Well, let's take a look at that. 4x cubed, and that's all there is to it. 4 times 3 is 12, and then we bring it down 1, 4x cubed. That's it. Well, what would you do with something like this? Minus 2x cubed plus 3x. Well, you go 3 times minus 2, and that would give you 3 times minus 2 would give you minus 6, and then you subtract 1 away from it. So that's minus 6x squared. But what about 3x? Well, there's really a 1 there. So you go 1 times 3, but you go 1 minus 1. Well, that's 0, and 3 to the 0 is just 1. So when you have 3x, the gradient of that function, 3x, is just 3. Hey, that should make sense. 3x is like a line, 4x, 5x, and the number in front of x is the gradient. So you can just write down the gradient. It doesn't change. It goes constant. That gradient's constant. Whenever you see x, you can just write down the coefficient. That'll be the gradient. But you're still following this thing, 1 times 3, and then 1 minus 1 is 0, so there you go. Okay, let's look at the next one. What if you had 3 over x squared? Well, now that's a problem, and it's a problem if you don't know about negative exponents. You can take this x to the 2 and really write it as x to the minus 2. So that's your first step, and they actually give you a mark just for doing that. Instead of putting x down there, you can put the x up here and put it to the minus 2 power. In fact, that's what negative exponents mean. That x to the 2 in the bottom means x to the minus 2 in the top. Now we multiply it, negative 2 times 3, that should give me minus 6. But if we subtract 1 from minus 2, it'll turn into minus 3. So there you go. Let's look at the next one. Here's one. How would we do this? Minus 6 to the cubed root of x squared. Ooh, that's a problem because it's got to be in the form of x to a 1 power. Well, you have to be able to know how to turn surds into powers. And the way you do it, whenever you see the little root there, if it's a square root, there's really a 2 there. That 3 actually goes to the bottom and makes a fraction. It's really x to the 2 over 3. So you have to know that about surds. When you're taking a surd, you want to change it into a rational exponent. What you do is take that little root and put it in the bottom of the fraction. And now we've got it because it's ax to the n, minus 6x to the 2/3. We can multiply it by what's in front, minus 6 times 2 over 3. I think that's minus 4. Now you get weird numbers here. You go 2 over 3 minus 1. If you know your fractions, that's 3 over 3. 2 minus 3 is negative 1 over 3. Or you can put that in your calculator and it'll just give you the right answer every time. What about something like this? Well, this is 2 separate things. That's not ax to the n. But what if we did FOIL on this? And now you have to go 2x minus 1 over x times 2x minus 1 over x, and then multiply it all out. And if you do that carefully, you'll see that you get 4x squared, 2x times 2x, 1 over x times 1 over x, squared is 1 over x squared. But the outside and the inside, the x's cancel. You get minus 2 and another minus 2, you'll get minus 4. So multiply that out carefully, and you'll get that. Now let's do the derivative. Okay, oh, that 1 over x squared, that's no good. It's got to be in the form of ax to the n, so we've got to change it to x to the minus 2. Now we can do our answer. 2 times 4 is 8, and then x, 2 minus 1, x to the first power. Now, the gradient of a constant is always nothing. There's really x to the 0 there, and you could think of 0 getting multiplied by minus 4. But the gradient of a constant, it's like y equals minus 4. The gradient's always 0, so we don't put anything. If you just see 7, 10, a fraction, anything that isn't got x in it, even other letters, we consider them constants, and they have no gradient. But this minus 2, we multiply it by in front. Minus 2 times 1 is minus 2. Subtract 1 from minus 2. Minus 2 minus 1 is minus 3. So there's the derivative of this function here. There it is. A little bit tricky. Those are the three main different things you have to do. Sometimes expanding a thing, taking a surd and writing it as a rational exponent. You got to be able to do that. Or taking a power in the bottom and writing it as a negative exponent. So you can put it as ax to the power n. So that's our first introduction on how to do the shortcut of finding the derivative.